Topic of this video is increasing and decreasing function. This video is designed to solve the questions of NCERT exercise 6.2. To solve these questions, first we should know what is increasing and decreasing function. Suppose y equal fx be a function of x be a function of y in terms of x. Now, first increasing function. Suppose y equal fx is a function such that if x increases, it means if we move from left to right on the graph paper, then y either increases continuously or it is constant. If x increases, then y either increases or constant, then such functions are known as increasing functions. Second, if x increases, then y increases continuously. Such functions are known as strictly increasing function. Third situation, if x increases, then either y decreases or y is constant. Then function are known as decreasing function. Fourth, if x increases, then y reduces continuously. Such functions are known as strictly decreasing functions. And last situation, suppose this is the graph of the function y equal to fx. In this graph, from x equal a to x equal b, function is increasing. From b to c, function is decreasing. So in the whole interval a to c, function is neither increasing nor decreasing. We can decide the nature of the function y equal fx with the help of its first derivative dy by dx. These are the different values of y, and this is the nature of f. First case, if dy by dx is either 0 or positive, more than or equal to 0, then function is increasing function. If dy by dx is strictly positive, function is strictly increasing. If dy by dx is 0 or negative, then function is decreasing. If dy by dx is strictly negative, then function is strictly decreasing. You may note down this page or you may take its screenshot. Now we will solve few questions of exercise 6.2. We will start with question number 3, page number 205 of the NCERT textbook. Third question, given function is y equal fx equals sin x. If fx equals sin x is the given function, then prove it is increasing in first quadrant, it is decreasing in second quadrant, it is neither increasing nor decreasing in the quadrant in the interval 0 to pi. Now, fx equals sin x. Differentiate with respect to x. F dash x will be cos x. Now, first part, if x belongs to 0 to pi by 2, then it means this is first quadrant. So, cos x will be more than 0, that is positive. It means f dash x is positive. So, function is strictly increasing. It means obviously it is increasing also. Second part, if x belongs to pi by 2 to pi, this is second quadrant. In second quadrant, cos x is negative. So, f dash x will be negative. So, function is strictly decreasing. It means it is obviously decreasing also. Third case, if x belongs to 0 to pi, this interval includes first and second both the quadrants, but function is increasing in first and decreasing in second. So in the whole interval 0 to pi, function is neither increasing nor decreasing. You can take its screenshot or you can note it by pausing this video. Now next question is question number 5. Fifth question, same page 205. Find the intervals in which the function f given by fx equal this polynomial in x this polynomial in x, fx equal 2x cube minus 3x square minus 36x plus 7. Find out intervals where it is increasing and where it is decreasing. First step to solve this kind of questions, if fx equal any polynomial in x, first differentiate with respect to x. F dash x equal 6x square minus 6x minus 36. Now to find out the intervals, put f dash x equal 0. If f dash x equal 0, this implies 6 common, x square minus x minus 6 equal 0, or 6, this will be x minus 3 into x plus 2 equal 0. It gives x equal minus 2 and 3. Plot all these values of x on real number line every time from smaller to greater. This is minus 2, this is plus 3. There are two numbers, so it divides, these two numbers divide this real number line in 3 parts. Now start with extreme right. Every time start with extreme right. Sign of f dash x in the extreme right interval will be sign of highest, the sign of the coefficient of highest degree term in f dash x. In this f dash x, highest degree term of x is x square. Its coefficient is plus 6, so extreme right will be positive. Now if there is no repetition in factors, it has all different factors, then next will be negative, then next will be positive. Alternate plus minus plus minus plus. If there is no repetition in factors in factor form of f dash x, extreme right, sign of extreme right will be same as the sign of coefficient of highest degree term of f dash x. In this, highest degree term is x square, its coefficient is positive, so extreme right is positive, and then alternate plus minus, so on. Now you can write the nature of the function in all the intervals. Now prepare a table. First column is interval, second is value of f dash x, and third is nature of f. Every time we will prepare this kind of table in case of polynomial functions. First interval from minus infinity to minus 2, minus infinity to minus 2, and it is asking about increasing and decreasing functions. It is not asking about strict functions, so we will take closed intervals. So minus infinity to minus 2, next is minus 2 to plus 3, and last is plus 3 to plus infinity. At plus infinity and minus infinity, it will always be open interval, as plus infinity and minus infinity are not real numbers. Now in the interval minus infinity to minus 2, f dash x is positive or 0. In this interval, closed intervals includes its endpoints also, so it will be, in this interval it is either negative or endpoints it can be 0. This positive or 0. So nature of f in this interval, increasing, negative means decreasing, and last is increasing. You can note it down or you may take its screenshot. Now next question is question number 6, E part. E part of question number 6. Page number 205. Function is given fx equal x plus 1 whole cube x minus 3 whole cube. Find out intervals where function is strictly increasing or strictly decreasing. First, differentiate with respect to x. F dash x equal 3x plus 1 whole square x minus 3 whole cube as it is plus x plus 1 whole cube 3x minus 3 whole square. For calculation of intervals, put f dash x equal to 0. If f dash x equals 0, this implies it means 3 x plus 1 whole square x minus 3 whole square common, and it will be x minus 3 plus x plus 1 equals 0. It means 3x plus 1 whole square x minus 3 whole square into 2x minus 2. It means x is either minus 1 or plus 1 or plus 3. Plot these numbers on real number line. Minus 1, 1, 3. Extreme right interval. It will be positive, as coefficient of highest degree term of x will be positive. Highest degree term will be x to the power 5 if you multiply these expressions, and its coefficient will be plus 6. Second, extreme right interval is positive if we are causing 3. Number 3 is obtained by putting x minus 3 whole square equal to 0. Its exponent is an even number. In case of even number, we will not change the sign. This is positive, we will continue the same sign. As 3 is obtained from x minus 3 whole square, so we will not change the sign. If its exponent will be 1 or 3 or 5, then we would have been changed sign. But it is an even number, so sign will be continue as it is. Now next number is 1, obtained from 2x minus 2, having exponent 1, odd number, so change the sign. Next is minus 1, obtained from the factor x plus 1 whole square. Obviously an even number, so there is no change in the sign of f dash x or first derivative. Now we have sign of f dash x in all the intervals, so we can prepare our table. First column is intervals, second is value of f dash x, and third is nature of the given function, nature of f. Now intervals are asked for the question for the functions where it is strictly increasing or strictly decreasing, so we will take open intervals this time. It means minus infinity to minus 1, minus 1 to 1, 1 to 3, and 3 to infinity. F dash x is negative, negative, positive, positive. It means function is strictly decreasing, strictly decreasing, strictly increasing, and strictly increasing. This is your question number 6. And now last question, question number 14. question number 14, page number 206. For what values of a, the function f given by fx equal x square plus ax plus 1 is increasing on the interval 1 to 2. It means given function fx equal x square plus ax plus 1. Find out the possible values of a for which function is increasing on the given interval 1 to 2. So first differentiate with respect to x. F dash x equal 2x plus a. Now for increasing function f dash x should be greater than or equal to 0. It means 2x plus a should be greater than or equal to 0. It means a should be greater than or equal to minus 2x, but it is given x belongs to interval 1 to 2. This implies minus 2x belongs to minus 4 to minus 2. It means minus 2x may have any value varying from minus 4 to minus 2, and a should be greater than all such values. It means this implies a should be greater than or equal to minus 2. For these values of a, function will be increasing. A is more than or equal to minus 2. Thank you.